we study the tensors corresponding to this one row Young diagram. So the Young operator is just the total symmetrizer, sum over all permutations in Sn. And here we have n boxes, little n. And we want to study this in an example. So little n is 3. We have 3 boxes now. And capital N, that's the dimension of the base space from which we started. So we can write our Young operator explicitly. It's the total symmetrizer. It's 1 over 6 identity plus 1, 2 plus 1, 3 plus 2, 3. And now come the cyclic permutations 1, 2, 3 and 1, 3, 2. Okay, and we can apply this Young operator to any vector in V tensor, threefold tensor product of our V. Okay, let's start with, say, ES applied to 1, 1, 1. So V was 2-dimensional, that is threefold tensor product is 8-dimensional, and we choose a product basis again. So we have for each of these numbers here, we have the choice of 1 or 2. Now this one here is invariant. No matter how we permute the 3 numbers, we always get back 1, 1, 1, 1, 1, and we get this 6 times and divide by 6. If we apply the ES to, let's say, 1, 1, 2, then we get 1 over 6. When we apply the identity, we get 1, 1, 2. When we permute the first 2 numbers, we get 1, 1, 2 again. So we get this one here twice. Now when we permute the first and the third number, as in here, we get 2, 1, 1. And that we also get from one of the cyclic permutations at the end, so we get it twice. And finally, when we permute the second and the third number, then we have 1, 2, 1, and that we also get a second time from the other cyclic permutation. So this is the next vector we find, and here we can cancel the 2 and write it like this. Similarly, if we exchange all the 1s for 2s and the 2 for a 1, then we get 1 over 3, 2, 2, 1 plus 2, 1, 2 plus 1, 2, 2. And finally, when we apply ES to 2, 2, 2, that's invariant again. And of course, if we apply ES to, say, this one here, we get the same result as here, and so on. So these are all the vectors we find by projecting with this total symmetrizer. And now we find four vectors that each spans a one-dimensional subspace, and this subspace always carries the trivial representation, because the trivial representation of Sn corresponds to this one-row diagram. So in this 8-dimensional space here, there are 4 one-dimensional subspaces carrying the trivial representation.